Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Bertemu kita kembali dalam chemistry bersama Madam Hatini. Untuk hari ini, kita akan belajar topik electrochemistry bahagian pertama iaitu Galvanic Cell. Okay, objektif untuk subtopik Galvanic Cell, number 1, define electrode potential. Number 2, draw a voltaic or galvanic cell. Number 3, describe the operation of voltaic cell. Number 4, state the functions of salt bridge. Number 5, express half cell equations and the overall cell reaction equation. And the last one is illustrate a galvanic cell using a cell notation. Electrochemistry is the study of electrochemical reactions that involves interconversion of electrical energy and chemical energy in electrochemical cells. There are two types of electrochemical cells. Number 1, galvanic or voltaic cell, and number 2 is electrolytic cell. The difference between galvanic and electrolytic cell: galvanic cell turns chemical energy to electrical energy, while electrolytic cell turns electrical energy to chemical energy. Difference number 2, galvanic cell is a spontaneous reaction. So what is spontaneous reaction? Spontaneous reaction is a reaction that has a natural tendency to occur and does not require an energy input for it to occur. While non-spontaneous reaction is a reaction that cannot happen naturally and needs an energy input to help it to occur. That's why kalau you tengok di sini, electrolytic cell dia menggunakan bateri because dia perlukan sumber tenaga untuk menghasilkan chemical energy. Electrochemical reactions involve redox reactions. What does it mean by redox? Redox, RED stand for reduction, OX stand for oxidation. Okay, for example, copper 2 plus to copper. So copper 2 plus, the oxidation number for copper 2 plus is positive 2 and the oxidation number for copper solid is 0. So the reduction occur from copper 2 plus to copper solid. Okay, while zinc, from zinc to zinc 2 plus, the increasing of oxidation number. So increasing of oxidation number means oxidation process occur. So the redox reactions means reaction involving both oxidation and reduction occur at the same time. So from oxidation is the process that occurs when species donates or loses electrons with an increase in oxidation number, while reduction is the process that occurs when species gains electrons with decrease in oxidation number. So points to remember here: oxidation, increase oxidation number and loss electrons, while reduction, decrease the oxidation number and gain electron. Okay, now we look at the definition for oxidizing agent, or we call oxidant, and reducing agent. Oxidizing agent is species or reactant that undergoes reductions and gains electron. Okay, for example, copper 2 plus undergo reduction and it gains electron. So copper 2 plus electron to produce copper. So copper 2 plus will become oxidizing agent, or we call oxidant. While reducing agent is a species that undergoes oxidation. So which species that undergo oxidation is zinc. Zinc solid. So zinc solid undergoes oxidation and produce zinc 2 plus ion. So zinc donates electron. Okay, zinc donate electron and become zinc 2 plus. Okay, now definition for spontaneous reaction, a reaction that has natural tendency that to occur and does not require an energy input for it to occur. Okay, for example, in a galvanic cell for rusting of iron. Okay, non-spontaneous reaction, as I said before, a reaction that cannot happen naturally and needs an energy input to help it to occur. For example, photosynthesis in electrolytic cell. Okay, next, what is electrode potential? Electrode potential, the electrical potential difference produced between the electrodes and the solution in a half cell is called electrode potential of metal. And electrode potential cannot be measured directly. And what is cell potential? So cell potential between individual potentials of the two metal electrodes with respect to the electrode. Okay, for example, we look at the question 1. Copper solid plus 2 mole of silver ion produce copper 2 plus and 2 mole of silver atom. Identify the oxidizing and reducing agent. Okay, so kita ambil copper menjadi copper 2 plus. So from copper, the oxidation number for copper solid is 0. And the oxidation number for copper 2 plus is positive 2. So increasing oxidation number. So copper undergoes oxidation. Okay, copper undergoes oxidation while silver ion from positive 1 turn to 0. So silver ion undergoes reduction. So copper is oxidized to copper 2 plus and silver ion is reduced to silver atom. So the oxidizing agent is the species that undergoes reduction. So which one undergoes reduction? So the answer is silver ion. So silver ion undergoes reaction. So silver ion is oxidizing agent. While reducing agent is species that undergoes oxidation. So the species that undergo oxidation is copper solid. So the oxidizing agent is reduced and the reducing agent is oxidized. Okay, next, the definition for electrode. Electrode is solid conductor, carbon rod or metal that allows electrons to pass through it. And anode, electrode at which oxidation occurs, while cathode is electrode at which reduction occurs. So point to remember here, you just remember the red cat. Okay, red means reduction at cathode. Okay, this is the diagram for the galvanic cell. Okay, now kita tengok macam mana proses galvanic cell ni berlaku. Okay, galvanic cell is an electrochemical cell that converts chemical energy through spontaneous reaction into electricity. It consists of two half cells. Okay, two half cell yang ni dan juga yang ni. A half cell consists of an electrode, okay, ini electrode, immersed in a solution of its ion. Okay, for example here, zinc metal, okay, ini zinc metal, immersed in zinc 2 plus aqueous solution. So dia terendam dalam larutan zinc 2 plus. Okay, while copper metal ataupun copper electrode immersed in copper 2 plus aqueous solution. So dia terendam dalam ionnya. Okay, immersed in a solution of its ion. Okay, this is anode, half cell at anode. Okay, this is cathode. Okay, now these two electrodes, zinc and copper, are connected by wire. And a voltmeter is used. Okay, this is a voltmeter. Is used to measure the amount of electric current ataupun kita panggil sebagai voltage. Okay, jadi elektron will flow from anode to cathode. Ini adalah arah pengaliran elektron. So, elektron akan lalu melalui wire, melalui voltmeter. Jadi, voltmeter akan memberikan bacaan voltage dia. And then, the two containers of electrolyte, okay, the two containers that contain electrolyte tadi, connected by salt bridge. Normally, salt bridge terdiri daripada potassium nitrate or potassium chloride solution. So, the standard reduction potential for copper, okay, penulisan dia E0 copper 2 plus 2 copper, okay, maksud tulisan ni bermaksud copper 2 plus undergo reduction and become a copper. So, nilai dia adalah positive 0.34 volt. And the standard reduction potential for zinc 2 plus root zinc means zinc 2 plus 2 electron and produce zinc. Okay, so nilai dia adalah negative 0.76 volt. Okay, copper metal is made the cathode. Why? Why we said that copper metal is made the cathode? Okay, this is because the standard reduction potential for copper is more positive. Okay, more positive than the standard electrode potential for zinc. So, copper 2 plus tend to accept or gain electrons and undergo reduction. Jadi, kalau kita nak pilih spesies mana yang berada di cathode, kita tengok nilai standard reduction potential yang more positive. So, yang more positive tadi akan berada di sebelah cathode because dia akan mengalami proses reduction. Jadi, kalau copper reduction means zinc akan undergo oxidation. So, at anode, electrode at which oxidation occur, jadi zinc akan undergo oxidation and become zinc 2 plus. So, electrons are released at the anode. Okay, kita tengok anode Electron are released at the anode, which is a negative terminal. Thus, the anode has a higher electron density than the cathode. Okay, kalau kita lihat di sini, zinc 2 plus tadi, dia akan undergo oxidation and it become zinc 2 plus. Okay, jadi maknanya nanti elektrod zinc tadi, lama-lama dia akan makin menipis. Kerana apa? Kerana dia telah bertukar ataupun mengalami oxidation dan dia menjadi zinc 2 plus. So, bila dia jadi zinc 2 plus, maka at anode has a higher electron density than cathode. Okay, maknanya jumlah electron density kat sini terlalu banyak at the anode. Okay, while cation migrate to the cathode. Cation migrate to the cathode, so the positive terminal. So, anion in the electrolyte move to the anode, the negative terminal. So, as a result, the electrons move from the anode to cathode in the external circuit. Okay, electrons move from anode. Nampak arah pengaliran elektron from anode to cathode in external circuit. So, at the anode, zinc 2 plus ion are produced and move into the electrolyte. Okay, jadi disebabkan oleh zinc tadi, okay, zinc dia akan undergo oxidation. So, bila dia undergo oxidation, dia akan menjadi zinc 2 plus. Jadi, zinc 2 plus ion and move into the electrolyte. It means that the concentration of zinc 2 plus dalam bekas ni akan meningkat. Okay, it means that the concentration in the electrolyte increases. So, the electrolyte becomes more positive. Jadi, To maintain the electrical neutrality of the electrolyte, the anion from the salt bridge, kita tengok salt bridge kita adalah potassium nitrate. Jadi potassium nitrate tadi, okay, potassium nitrate KNO3, dia akan jadi K plus and nitrate ion. Okay. Jadi, to maintain the electrical neutrality of the electrolyte, the anion, which is NO3 minus, from the salt bridge move into the electrolyte of zinc nitrate. Maknanya, yang nitrate ion tadi akan masuk di sini. Okay, so tujuan dia adalah untuk meneutralkan kembali larutan electrolyte ni. Sebab larutan electrolyte ni jadi terlalu positif. Okay, sebab apa? Sebab penghasilan zinc 2 plus hasil daripada oxidation of zinc solid. Okay, jadi fungsi salt bridge di sini adalah untuk maintain the electrical neutrality of the electrolyte. Okay, jadi NO3 minus ion negatif daripada salt bridge akan meneutralkan zinc 2 plus. While the cation from the salt bridge will move into the electrolyte of copper nitrate. Jadi ion K plus akan bergerak ke sini. Kenapa dia bergerak ke sini? Disebabkan oleh ion copper 2 plus tadi dalam ni, copper 2 plus undergo reduction and become copper solid, menyebabkan ion copper 2 plus dalam ni makin berkurang. So when the concentration of copper 2 plus decrease, so the K plus ion from salt bridge akan move to this electrolyte to maintain the neutrality. Okay, what is salt bridge? Salt bridge is an inverted U-tube containing a jar permeated with solution of inerts such as saturated potassium chloride, potassium nitrate, or ammonium nitrate. So the function of salt bridge, number 1, is to complete the electrical circuit by permitting the ions to flow through it, and B, to maintain electrical neutrality in electrolytes. Now, what happens if there is no salt bridge? Without salt bridge, the reaction will stop because there would be a build-up of charges in the two half cell which would stop electrons from flowing in the wire. That's why the reaction will. Okay, so seperti yang saya terangkan tadi, at the left side, zinc solid dia become zinc solid turn to zinc 2 plus 2 electron. So zinc 2 plus ion enter the solution causing a net excess of positive charge. Maknanya concentration of zinc 2 plus makin banyak. Okay. Jadi chloride ion, chloride ion ataupun dalam kalau yang ni kalau kita guna salt bridge KCl, so dalam gambar je tadi kita guna NO3 minus. So the NO3 minus ataupun the anion from salt bridge move into zinc half cell. While at the right side, copper 2 plus reduce to copper solid. Jadi copper 2 plus ion leave the solution, causing an overall excess of negative charge. Kenapa? Kerana ion copper 2 plus telah bertukar menjadi copper solid. Jadi macam mana nak maintain neutrality? So the K plus ion from the salt bridge move into copper half cell. Jadi salt bridge, salt bridge boleh terdiri daripada KCl solution ataupun potassium nitrate solution. So dalam gambar aja tadi kita guna potassium nitrate dan dia juga boleh jadi potassium chloride. Jadi maknanya di sini anion from the salt bridge lah. Anion from the salt bridge. So as a result, the electrical neutrality is maintained. From the diagram, we can write the half cell equation and overall reaction. Now at anode, which is oxidation process. So zinc solid will undergo oxidation and become zinc 2 plus, while at the cathode, which is reduction process, copper 2 plus undergoes reduction and produce copper solid. Okay, so this one we call half cell reaction at anode and cathode. So kamu kena tulis tau. Maksudnya bila nak tulis half cell equation, mesti kena label anode or cathode. Okay, so now we kena pastikan bahawa elektron, jumlah elektron pada anode dan juga cathode mestilah sama. Okay, so bila sama kita boleh cancel. And finally, we can get the overall equation, which is copper 2 plus zinc solid produce copper solid and zinc 2 plus aqueous. Okay. Okay. So point to remember, before combining the two half equations, ensure the number of electrons in the equation are the same. If not, multiply the half equation by a factor. Maknanya kita kena pastikan bahawa jumlah elektron at anode dan juga cathode ni mesti sama. So kalau dia tak sama, kita kena darab mana-mana equation supaya kita boleh dapat sama dan at the end kita boleh cancel. Okay, dia punya elektron tu. Okay. Daripada diagram tadi, kita boleh tulis cell notation. Apa dia cell notation? Cell notation is a shorthand way of expressing a certain reaction in an electrochemical cell. So the cell anode and cathode, okay, which are half cell, are separated by two bars of slashes representing a salt bridge with anode on the left and the cathode on the right. Okay, kita tengok macam mana cara kita nak tulis cell notation. Okay, cell notation. Okay, the cell of anode and cathode are separated by the two bars ataupun kita kata two slash kat sini So slash di sini means salt bridge. Okay, slash means salt bridge. Okay, at the left side is anode, at the right side is cathode. Okay, phases of the reactants and product must be indicated. Concentration of ion or pressure of gas also must be specified if it is known. Okay, slash represent phase boundary within a half cell and use comma between two species of the same phase. Okay, double slash designate the salt bridge connecting the two half cells. Okay, so cara nak ingat, kita boleh ingat kat sini, oil means oxidation is on the left. Oil, oxidation is on the left. Okay. Half cell components usually appear in the same orders as in the half reaction, and electrodes appear at the far left and right of the notation. So electrodes must be solid conductors. Okay, kita lihat macam mana cara kita nak buat cell notation. Okay, kita ada kat sini diagram, galvanic cell diagram. Okay, now kita tengok anode, cathode. Okay, anode, cathode. So, bila kita nak tulis cell notation, anode ataupun oxidation process berlaku, kita tulis di sebelah kiri, manakala cathode di sebelah kanan. Jadi, anode, zinc solid undergoes oxidation and produce zinc 2 plus. That's why dia tulis kat situ zinc zinc 2 plus. Because zinc undergoes oxidation. While at cathode copper 2 plus aqueous undergo reduction and produce copper solid. Kita nampak sini copper 2 plus undergo reduction and produce copper solid. Kita letak slash, nampak slash? Slash means different phases. Double slash means salt bridge. Okay. Salt bridge. Jadi, salt bridge ni akan menghubungkan antara two electrolytes. That's why kalau you tengok, di sebelah double slash ni, dia diapit oleh aqueous solution. Okay, aqueous solution. Sebab dia menghubungkan dua electrolyte. And this electrolyte connected with electrode metal. This one pun sama juga. Electrolyte connected with electrode metal. Anode undergoes oxidation. So from zinc become zinc to plus. Okay, while copper to plus undergo reduction. That means from copper to plus reduced to copper. Okay, look at this question. A galvanic cell consists of a magnesium electrode immersed in 1 molar magnesium nitrate solution and a silver electrode immersed in 1 molar silver nitrate solution and a salt bridge. Given the standard reduction potential for magnesium is negative 2.37 volt and the standard reduction potential for silver ion is positive 0.8 volt. Write the half reaction at anode and cathode. B. Write the cell notation for the above reaction. And C. State the oxidizing agent. Okay, look at this example. A galvanic cell consists of magnesium electrode immersed in 1 molar magnesium nitrate solution and a silver electrode immersed in 1 molar silver nitrate solution and a salt bridge. Given the standard reduction potential for magnesium is negative 2.37 volt and the standard reduction potential for silver is positive 0.8 volt. Okay, A. Sketch the cell indicating the flow of electrons, anode and cathode terminals. Jadi kalau kita lihat di sini, okay, this is a galvanic cell. Jadi kita akan lukis gambar rajah bagi galvanic cell. So, galvanic cell terdiri daripada two beakers. Okay, dihubungkan oleh salt bridge. And then there are two electrode. Okay, these two electrode immersed in their electrolytes. Okay, make sure the salt bridge and the electrode immersed in the electrolyte. These two electrode connected with wire and the wire connected with the voltmeter. So, ini dia punya basic dia lah. Okay, untuk cell diagram. Okay, now kita nak choose which one is cathode, which one is anode. Okay, cathode adalah nilai standard reduction potential dia more positive. So, bila kita lihat antara dua ini, yang more positif adalah silver. Jadi, silver akan jadi cathode. Okay, silver immersed in silver ion. Okay, look at the concentration of silver ion. 1 molar silver nitrate solution. Okay, so boleh tulis sama ada silver ion ataupun kita boleh tulis sebagai silver nitrate. So, let's say kalau kamu nak tulis kat sini silver nitrate pun okay. Okay, so tulis silver nitrate AgNO3 aqueous dan konsentrasinya adalah 1 molar. Kalau yang ni adalah cathode, so sebelah sini adalah anode. So anode kita adalah magnesium immersed in magnesium nitrate. Okay, immersed in magnesium nitrate. Aqueous. Okay, don't forget to write the concentration of the electrolyte. Okay, then this is voltmeter. Okay, this one salt bridge. Okay, now don't forget to write the position of cathode and anode. Okay, silver will become cathode and magnesium is anode. Then finally, we draw the flow of electrons. So electron flow from anode to cathode. Okay, electron flow. So this is the cell diagram for the galvanic cell. Okay, next we go to the question B. Write the half reaction at anode and cathode. Okay, so write there anode. Okay, at anode magnesium magnesium akan jadi anode. So magnesium dia akan jadi magnesium 2 plus equals plus 2 electrons. Okay, because anode undergo oxidation and cathode silver ion plus electron, it become silver solid. Okay, at cathode 1 electron, at anode 2 electron. So we need to multiply with 2 supaya bilangan elektron akan jadi sama. So bila kita multiply dengan 2, dia akan jadi 2 Ag plus equals plus 2 electron produce 2 Ag solid. Okay. Okay, ini adalah half reaction at the anode and cathode. Okay, katalah dia minta kita write the overall equation. So, kalau overall equation, dia akan jadi magnesium solid plus 2 Ag plus equals produce magnesium 2 plus equals plus 2 Ag solid. Okay, so this is overall equation. Okay, so kita dah sketch. Kita dah write the half reaction at the anode and cathode. Okay, yang saya star ni adalah sekiranya dia tanya kita write the overall equation. So, kita boleh tulis overall equation. Okay, C, write the cell notation for the above reaction. Okay, cell notation ni, dia sebenarnya menggambarkan dia punya galvanic cell ni, gambar rajah galvanic cell. Okay, jadi kita akan mula dengan tulis anode dulu. So, magnesium solid slash magnesium 2 plus equals 1 molar. Okay, don't forget to write the concentration. Okay, double slash means salt bridge. Okay, nampak magnesium. Ini magnesium solid. Immerse dalam magnesium 2 plus equals, iaitu yang ni. Okay. Dan dihubungkan oleh salt bridge, iaitu yang ni. Okay, dihubungkan melalui salt bridge. So, salt bridge akan mengalirkan punya charge. Okay. Dan connected dengan apa? Connected dengan Ag plus. Okay, connected dengan Ag plus equals. Okay, ini dia punya electrolyte dia lah. Okay, jadi kita akan tulis kat sini. Magnesium. Okay, dan Ag plus. Okay, dan Ag plus ini telah di-connect oleh Ag solid, iaitu dia punya electrode. Okay. So, ini adalah cell notation. So, kita dah jawab yang dah. Yang ni A. Yang ni B. Okay, this is for question C. Okay, katalah dia minta electron flow. Electron flow from anode to cathode. Okay, nampak electron flow daripada solid, iaitu daripada electrode ke electrode cathode. Jadi, kita boleh buat pada kita punya cell notation, the flow of electron. So, daripada anode to cathode. Means daripada magnesium solid, iaitu magnesium electrode, to silver electrode. And the last one is D. State the oxidizing agent. So, oxidizing agent undergo reduction. So, yang undergo reduction adalah siapa? Adalah silver ion. So, silver ion undergo reduction. So, silver ion will become oxidizing agent. Okay, jadi answer dia adalah silver plus. Okay, thank you very much.